Hello, this movie is on Learning Target 4 using corresponding parts of congruent triangles. So what we've learned so far is that we can prove two triangles congruent using shortcuts. Well, if we wanted to prove certain parts of those two triangles congruent, we could say that once the triangles are congruent, then all corresponding parts are congruent. So we have an acronym for this. It says using corresponding parts of congruent triangles are congruent. So CPCTC, this is a legit acronym that we use. It is on the state assessment that way. Sometimes it's written out, sometimes it's used as CPCTC, but that's how you say it, CPCTC. Corresponding parts of congruent triangles are congruent. Once you can prove two triangles congruent by any of the following shortcuts. Let's list out the shortcuts we know to be true. Side, 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 angle, side, angle, side, angle, and angle, angle, side. I know that to be true because the two ways that don't work are donkeys on vacation. So I know those don't work. You can say that all the triangles corresponding parts are, so once you've established this, then we can say that all of their corresponding parts are congruent. So, very convenient. Once you prove two triangles congruent, then their corresponding parts are congruent. So let's look at this proof. We've got the given. I'll do the lazy man given. And we know that that is because of given. Is it marked on the diagram? Yes. BC is congruent to BC because of reflexive property. Now, looking at the diagram, I have everything marked. Do we have enough to say by a shortcut that the two triangles are congruent? Yes. Which method are we using to prove triangles congruent? We've got angle, angle, side. Now that we've established these two triangles congruent, what I know is that all their corresponding parts are congruent. So to say that KB, this side, is congruent to AC, that's what I'm trying to prove. So after I've established the two triangles congruent, I can say that's true because corresponding parts of congruent triangles are congruent. Now you can write that out, but CPCTC. Some students tend to forget that acronym. You can remember it because Coach Peters can touch ceilings. That's another way of remembering it because we all know that Coach Peters is pretty tall. Coach Peters can touch ceilings. CPCTC. It's establishing all corresponding parts congruent. Let's look at this next one. We've got our given. And the diagram is marked with the given. What allows us to say angle CAB is congruent to EAD? Well, those are because vertical angles are congruent. Do we have enough to say that the two triangles are congruent? Yes, we do. We have side, angle, side. Now, what allows me to say that angle C must be congruent to angle E? Well, once I've established both triangles congruent, I know that all the corresponding parts are congruent. Corresponding parts of congruent triangles are congruent. Here we have a little bit of the statements. Some of the statements are not marked. The first part is from the given, so AB is congruent to AD. BC is congruent to DC. Down here, line 3, I had another given, so angle D is congruent to angle B. And I'm noticing all these are marked on the diagram as well. Angle DAC is congruent to angle BAC. Going back up to line 2, reflexive property, you can see that AC is congruent to AC. Reflexive property. Because of the third angles theorem, well, I've got two angles of one triangle congruent to two angles of another. Therefore, third angle is congruent. So I can say that these two angles are congruent to each other. Angle DCA is congruent to angle BCA. Now the two triangles are congruent, and if I list it as ABC, that's got to be congruent to ADC. So some proofs will have you filling in the statements. So this Greek philosopher is said to develop a method to measure the distance to a ship at sea. He made a compass by nailing two sticks together, standing on top of a tower. He would hold one stick vertical to the tilt and tilt the other until he could see the ship S along the line of the tilted stick. With this compass setting, he would find a landmark L on the shore along the line of the tilted stick. How far would the ship be from the base of the tower? So you can see what we've established here are two triangles. If we can prove these two triangles congruent, then we know all the corresponding parts are congruent. So when we're trying to prove that RS here, this distance, is congruent to RL, what I can do is prove the two triangles congruent and then say that corresponding parts are congruent. So I've put the diagram down here as well with the statements. And let's look at what we have. The first one, RTS, is given. Those two angles are given. TR congruent to TR, that's reflexive property. Angle TRS and TRL are right angles. That was also given. Angle TRS and angle TRL now are congruent because what we know is that all right angles are congruent. Now the two triangles, if I've established these two angles as congruent, the two triangles will be congruent by angle, side, angle. Because you've got angle, side, angle, congruent to angle, side, angle. Then the last step, what allows you to say that RS must be congruent to RL? Corresponding parts of congruent triangles are congruent. CPCTC. Proving triangle parts congruent to measure distance. So here we've got AB is congruent to AC. M is the midpoint of BC. Prove these two angles congruent. So in the given, we've got AB congruent to AC. M is the midpoint of BC. And by reflexive property, AM is congruent to AM. Now, because M is the midpoint of BC, by definition of midpoint, I get that these two segments are congruent. So BM congruent to CM by definition of midpoint. Then I've got by side, side, side of one congruent to side, side, side of the other, triangle AMB is congruent to triangle AMC. So now I've established the two triangles congruent. Corresponding parts of congruent triangles are congruent, so angle AMB will be congruent to angle AMC, which is what we want to prove. So this one is for you to work on if you would like. I just wanted to give you some extra proofs to work on. And that's the end of this movie. Thank you for watching.